my name's Harris. I'm joined here with Dustin, Otniel, and Jordan. Our project is all about product analysis. So let's continue. I'll start off by giving a quick overview of our presentation. I'll talk about our goals with the project, as well as describe the tools we used and the data we collected for our project. In addition, we'll talk about the challenges we faced, as well as go into detail with how our web interface works, and then talk about some future improvements we could have done with the project, and to finish off with some closing remarks. For the purpose of our project, we wanted to compare products across multiple websites. We wanted to capture as much data to fit the project requirements. So we chose to collect data from big name online retailers. And as such, our data set includes data from Target, Walmart, Amazon, and eBay. In order to better simplify our data and ensure compatibility between the different websites, we chose to only include the necessary product information. That includes basic identifying information like the name, description, and price, as well as other information including the store, the image link, and the product link. To show an example of the information we collected, here is a schema for our table that we collected from Target. As you could probably see, we have all the relevant information, but also some extra information that we couldn't include. It's important that in our final big table of all the companies that we collect, that they have shared attributes, and it's important that we analyze the data between these shared attributes.
We used PySpark to load our dataset from a CSV file into a data frame. We then processed the data to find the number of products for each category, the average price for each category, and the average price for each brand. Finally, we stored the results of our analysis into a SQLite database. We ran into a couple of challenges when trying to process our data. In the beginning, we found that some of the scripts we wrote would have taken over an hour to complete, and this was because we weren't using PySpark efficiently. We were constantly moving data back and forth between Python and Spark, which was inefficient. We found that if we performed all the data processing using Spark functions, then it would have been much quicker. The script to find the average price by category went from taking over an hour to just a couple of minutes. Another problem we ran into was that we were running out of memory, and this was related to the first problem where we were constantly moving data between Python and Spark. Calling .collect on the large data frames used a lot of memory because it would have to pull everything from Spark into Python. We overcame this problem by finding ways to do all of the data processing using Spark functions instead of having to pull the data into Python and iterating through it.
For our project, we are using the Django framework. Upon entering our website, the user is directed to the homepage where they can search for an item using the name, category, or description. After searching for an item, the user is redirected to the query page. In this page, the user can scroll up and down to browse the items that are relevant to their search. If they would like to search again, at the top of the page, they can re-enter a search, or they can click the Home tab in the menu bar, which will redirect them back to the page previously shown. This slide goes over the back end of how we implemented search. In the top snippet, you can see the HTML template. So this is the div for the search bar. Here we have the input for the search bar and the submit button, and that is all wrapped inside a form tag. The form tag action is set to the query page, which is configured inside our URLs and views.py. This form tag is also set to post method. That way we are able to get the information inside the form from our backend. Also, we need to use a CSRF token CSRF stands for Cross-Site Request Forgery and it is used in Django for security purposes. What it does is it generates a unique token in the server side, which is passed to the client side via HTTP request. In the bottom snippet, you can see in our views.py that we are retrieving the input from the user, and we're saving it in a variable called search term. After doing this, we're able to integrate this with our filtering logic.
After making a query search, users will be able to analyze the data even further. While we plan to add more choices and potentially change the ones we're working on, the goal right now is to allow users to see different charts like the price comparison graph you see here. The search term variable we talked about previously, alongside the functions from the matplotlib Python library, will be what we use to visualize the data. Aside from analyzing the query results, you can also click on any of the listed items to pull up this product page. From here, you'll be able to see more information about a product, like the site the product is from, its description, a link to go to the site where the product was found on, and potentially more. In the future, we plan to do a better job scraping the data so we can get more stuff from each crawl. This will allow us to add even more features, like including reviews on the product page. Another potential feature could be finding the same product across multiple sites, and then allowing the user to compare things like price, sales, and shipping costs and time. We're also still working on the best way to present all this information on the product and query results pages, as well as figuring out how to include things like filters that can resort the results page from lowest to highest price or by brand or store. And with that, we thank you for listening.